Hello and welcome to November Space News Recap. This is a series where I cover all the space news that you might have missed in the last month because the space industry is booming right now and there is so much going on, it can be really overwhelming. But that's my job as a space communicator, so without further ado, let's dive in because November was crazy. First up, we have the SLS for Artemis II, the Space Launch System. The SLS's solid rocket boosters are finally being stacked together or integrated into the full rocket at NASA's VAB, or the Vehicle Assembly Building at Kennedy Space Center. Now, there have also been developments for Artemis III, which is going to be the first landing back on the moon in a couple of years following Artemis II. In August of 2022, NASA announced that there were 13 candidate sites they were evaluating for that Artemis III landing, and now, as of November, there are only 9 of them. All of the potential landing sites are clustered around the lunar South Pole because we believe that there is a lot of water ice there that we can extract, purify, and use for drinking water, oxygen, or even rocket fuel. What they're looking for as they nail down the final landing site of these 9 candidates are things like surface conditions and the feasibility of actually landing a Starship there because it's a very craterous part of the moon. They're also looking at lighting conditions because the sun doesn't shine the same way on the South Pole as it does where we landed during the Apollo era. And they're also looking for direct to Earth communication visibility. So why is this important? Well, right now we don't have any communication satellites in orbit around the moon that you can send comms up to, and then those are relayed back to Earth. So right now for Artemis III, we have to have that direct to Earth communication line of sight so that NASA can make sure that the astronauts are okay and everything is going smoothly. We also got an update this month on the lunar terrain vehicles, the rovers that the astronauts are going to drive starting in Artemis IV and beyond later this decade and into the 2030s. The LTV is going to be an unpressurized rover, so the astronauts will have to wear their spacesuits just like in the Apollo days, and the companies currently working on that are Lunar Outpost, Intuitive Machines, and Venturi Astrolab. Lunar Outpost announced this month that they have selected Starship's lunar lander to bring that rover to the surface. No surprise there, it's kind of the only thing that can do that right now or in the near future. There's also a pressurized rover in development by the Japanese Space Agency. Actually, Toyota is building it. So all these car companies like Toyota and GM are involved in making lunar rovers for the moon, which is so cool. But anyways, they have decided that they are also using Starship to get them to the surface. Again, no surprise there, but that will happen in 2032. And that pressurized rover, you can basically think about it as a habitat on wheels. The astronauts won't have to wear their spacesuits inside, so they'll be able to do a lot more comfortable and long-term exploration in that. Okay, now moving on to robotic space exploration, we have a lot of big updates this month. We're going to start with the Nancy Grace Roman telescope. So this month, for the first time ever, all of the components for NASA's new flagship telescope that's going to launch in 2027 are under one roof at the Goddard Space Flight Center in Maryland. But more than just having everything under one roof, they've also made significant strides in actually building the instrumentation that Nancy Grace Roman is going to use to study things like dark energy and exoplanets. There are 2 primary instruments on the Roman telescope, the wide field instrument and the coronagraph, and they successfully integrated the coronagraph this month. The coronagraph instrument is designed to block starlight from distant stars so that we can, for the first time, directly image exoplanets. So right now, the only way we can look at exoplanets is through indirect methods, usually through something called transiting, where you basically look at a faraway star and you wait for an exoplanet to pass in front and you measure that dip in starlight. This is limiting and we can only see a handful of exoplanets this way. So having a coronagraph that blocks really far away stars so that we can see the exoplanets around it is going to revolutionize astrophysics and even the search for extraterrestrial intelligence. We also have an exciting update from the Voyager 1 spacecraft. So unfortunately in October, Voyager 1 stopped communicating with Earth, and we thought that that might have been the end of getting data back from it. But in November, engineers were able to restore that communication, and we're back to getting data from all 4 of the instruments that are still powered on. To be able to do this with a spacecraft 15 billion miles away from Earth that has been operating for 47 years is insane to me. Like, the things that we're able to do, this is why I love space. Anyways, we also have updates on 2 missions that are going to the outer part of our solar system, particularly around Jupiter and Saturn. So in October, NASA launched a mission called Europa Clipper. Europa Clipper is the first spacecraft dedicated to studying Jupiter's moon Europa. Why do we care? Well, we believe that under the icy crust of this moon, there's a subsurface ocean that could host all the key ingredients for life. So simply put, it's one of the most likely places for us to find microbial life beyond Earth, which we have not done yet. Since its launch in early October, Europa Clipper is now about 13 million miles away from Earth. It might seem far, but it actually has quite a long ways to go. It has to travel 1.8 billion miles to Jupiter. It won't arrive until 2030, but between now and then, scientists have already turned on some of the instruments, including the magnetometer and the radar instrument. So both of these instruments are going to help us understand more about that subsurface ocean and see if it's habitable and measure its depth and even its salinity. And the other deep space mission is something called Dragonfly. This is going to Saturn's moon Titan, again to study its habitability and to see whether it could have hosted life in the past. Dragonfly is scheduled to launch in a very tight launch window in July of 2028, and as of this month, NASA has decided that they are going to launch it on SpaceX's Falcon Heavy rocket. Shifting gears to rockets, there have been quite a few developments this month. First and foremost is Blue Origin's New Glenn. So this is their first orbital rocket. We've been waiting on this for a really long time, and in November, they finally lifted it vertical in preparation for its launch, hopefully in December. New Glenn is a heavy lift rocket, meaning it can lift a lot of things at once into space, just like SpaceX's Starship, which of course has also continued to make headlines this month. They completed their 6th successful test flight and are pushing forward to the 7th one, hopefully in early next year. But what I really wanted to cover on Starship this month is that they have publicly started to talk about the future of Starship. They've had a lot of successful test flights. What does the future look like? They've had 6 so far, as I mentioned. They're planning to launch 25 Starships next year alone. So 25 in 2025. Now, beyond that, they want to launch 400 Starships in the next 4 years. To put that into perspective, Falcon 9, which has been their workhorse for nearly 15 years, literally just last week completed its 400th successful flight. To meet that crazy launch cadence, they want to build 1 Starship every 8 hours. 1 rocket in 1 shift is, okay, let's be honest, it's a little crazy. I'm not saying they can't do it, but a lot of the industry is questioning why, and also, is this going to sacrifice safety? It would be really bad, obviously, if we had another catastrophic incident and they want to fly humans on this. So are they putting the right processes in place to make sure that that doesn't happen to the best of our ability? The other question I personally have is, why do we need that many? Isn't the whole point to be reusable? And also, what is that doing to the environment? Because building a rocket does not come without environmental impacts. So I'm curious to see what information they're going to release in the future. We'll just have to see what happens. But for now, honestly, I'm just thinking about what a feat of engineering and program management and supply chain that actually would be if they could achieve that flight cadence and that build rate. Okay, 2 more big things to talk about. The first of which is space data. So we have all these satellites up in space and so much data coming down. What do we do with it? And oftentimes we are data rich but insight poor. NASA has a whole fleet of Earth observation satellites that over the years have provided us with about 100 petabytes of data about the Earth. NASA is like, what do we do with that? Well, now we have AI. So NASA and Microsoft are actually working together on something called Earth Copilot. This is a customized version of Microsoft Azure's OpenAI platform and is intended to remove technical barriers to encourage a more diverse audience like scientists and educators and policymakers to explore and use NASA's Earth observation data. A lot of these data platforms are going to pop up in the coming years, so definitely stay tuned for that. And the last area I want to cover is a super important area. It's investment. It's private equity in the space industry. How do we go from a $630 billion industry today to triple that size, a $2 trillion industry in 2035. Here are 4 key investments that I saw in November. The first one is a company called Starfish Space. They raised $29 million to bring their total fundraising amount to date to over $50 million. They're in the satellite servicing part of the industry. Basically, right now, we can't service a satellite if it dies or runs out of fuel, like you would take your car into the shop. And so that part of the industry, and particularly Starfish, are looking at how do we solve that problem. This money is going to help them develop 3 of their initial Otter satellite servicing platforms, and these are going to service customers like Intelsat, the US Space Force, and NASA starting in 2026. Another round of investment was a $44 million Series A raised by a company called Inversion Space, and they are doing something super cool that I'm really excited to see come to fruition over the coming years and decades. And that is space-based cargo delivery anywhere in the world in under 90 minutes. So imagine you're a customer that needs something halfway around the world really fast. This could be anything from the military to 3D printed organs for people who need a organ transplant. Right now, Inversion is working on an autonomous reentry vehicle that basically you could stage cargo in space and then drop it anywhere on Earth whenever you needed it. And a couple of other companies are working on this. The DoD is really interested in this, and it's honestly really exciting to see more and more private equity investment into this part of the industry. The third investment was a whopping $175 million Series D raised by a company called Firefly. Their core business is responsive space services. So how do you launch something within a 24-hour notice, which they did for the DoD, I think it was last year or the year before. They have a small launch vehicle called Alpha, a medium launch vehicle that they're working on in partnership with Northrop Grumman, and they also have an uncrewed lunar lander that can take cargo to the moon for customers like NASA, the DoD, or commercial operators. And the last investment that I wanted to cover is the $160 million investment into the Exploration Company. This is a European company providing cargo delivery services to the International Space Station and future commercial space stations. Basically, Europe's equivalent of Dragon or Starliner or Northrop Grumman's cargo delivery vehicle. The $160 million is going to help them stay on track for a 2028 cargo delivery to the ISS. That timeline is pretty set because the ISS is currently set to be retired and crashed into the ocean in 2030. After the ISS, the Exploration Company plans to send cargo and maybe even humans to commercial space stations. They actually have an $800 million backlog from private companies like Axiom and Vast to do this. And the reason that this is really, really important is that it's a European company, and historically, European private equity investment, especially in the space industry, has not been anywhere close to what we're seeing in the United States. But with 98% of their cap table being European investors, this is a big moment for Europe to really make its moves in the space industry. If you'd like to dive deeper into any of these stories, feel free to ask me questions in the comments, and I'll also link additional resources in the description. Thank you so much for watching, and if you like this type of content, be sure to hit that subscribe button. And I have a really exciting interview that you guys definitely don't want to miss coming up in the next few weeks. All right, bye!